Hey everybody, I'm here to review a problem from section 5.3, which we covered right after exam 1, so it's been a few weeks. And this is a problem from the review as well. So you can read through that entire problem, but as you can see, they're giving us a table with ages and bone density, and if you read the question, step 1 of 6, they want us to find the estimated slope, round your answer to 3 decimal places. All right, so we will need Excel for this. So first, copy the data, and I'm going to pop over to Excel. So just know I have a Mac, so how my Excel looks might be just a little bit different from how it is on a Windows machine, but same idea. I also have directions on how to do all this stuff on Blackboard. Okay, so copy the data into Excel, and they're asking for the slope, which means we need to get a scatter plot, find the equation, or well, find a trend line first, and then find the equation for that scatter plot. And we'll just let Excel do all that work for us. So I'm going to highlight the data and insert and find your scatter plot button. It should be the very first option. All right, and we get a chart. So add a trend line. I'm going to go to add chart element, trend line, and then we've only done linear trend lines in this class, so that's what you want to do, linear. Okay. It fits a trend line to the data, but we need the equation now. So I'm going to right click on the trend line and select Format Trend Line. And then this brings up all these options. You scroll all the way down and there's 2 boxes you actually want to check. Display equation on chart, and we're also going to go ahead and check the display R squared value. And then you'll see it pops up. And let me actually, you have the ability to make this font bigger. Just, for me it's home. It might be home for you as well, but it also might be something different. I know some of the menus are a little bit different between, like the menu options are different between Macs and Windows sometimes. So yeah, just you can make the font bigger. And there we go. We can see that pretty well now. Okay, so I also don't have the ability to just kind of squeeze things into 1/2. You know, we did this in class. You could put 1/2 of the screen on one side, the other half on the other side. That's one really nice thing about Windows, but my computer does not do that. Okay. Question 1 was to find the estimated slope. Well, you get that directly from this equation here. And remember, the slope is always with the variable, right? With the x. So my slope here is negative 1.735. And they want it rounded to 3 decimal places, and we have 3 decimal places. So negative 1.735. And I guess I have to make that bigger so I can submit. All right, it's green. That means good job. We got it. Next question. Find the estimated y-intercept. Once again, this is all about reading the problem and the y-intercept. So the slope's with the variable, the y-intercept is the other number that's by itself. So we have 425.01. Submit. Good to go. All right. This one has 6 steps. So quite a lot going on here. Okay, this one I'm going to expand. Okay, let's read this problem. Determine if the statement, not all points predicted by the linear model fall on the same line, is true or false. So we have to be very careful here. They're talking about the linear model. The linear model is this line right here that we had Excel find for us. And the fact is, that linear model technically only predicts points that fall directly on that line, right? Now, this line doesn't perfectly fit every point. That happens, there's some error, but we found the line of what we call best fit. But if we're trying to predict future points, the fact is those points will live on that linear line. And there's no way around that. So, coming back to here, it says not all points predicted by the linear model fall on the same line. That is false because all points predicted by that linear model are going to be on that line. So false. Okay. Just so you know, there's really only two ways this problem is stated. You either see it like this, not all points predicted, blah, 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 or it says all points are predicted. And if it says that, if it doesn't have the not, then it's going to be true. All right. Step 4. Let me just make sure we're still working with the same data, so good. Find the estimated value of y when x equals 60. So we have to do some math here, and I'm just going to use Excel to do this because Excel does math. It's pretty handy. So remember, anytime you want to type in a formula, you have to start with equals. And by the way, I'm like all the way down here. I don't know why, I just picked that spot. And we're going to type in our equation. So equals, and then I'm going to put negative 1.735. Now, that's the slope, but we actually want to plug in an x value. So, and you multiply the slope by the x value. So I'm going to enter in times, or an asterisk, and then 60, because that's what we're plugging in. And then add your y-intercept, 425.01. Okay, so you can double check everything up here. It's the slope times the x plus the y-intercept. And Excel will read it in order, so you don't really need parentheses in this case. But if you always wanted, you could, just to make sure, you could put that first part in parentheses, whatever you want to do. So I'm going to hit enter. And then that should be our answer, 320.91. It says to round to 3 decimal places, but we only have 2, so you just type it in as it is. All right, awesome. Next. Okay. So, let's read this one. Substitute the values you found in steps 1 and 2 into the equation for the regression line to find the estimated linear model. According to this model, if the value of the independent variable is increased by 1 unit, then find the change in the dependent variable y hat. Okay, so first part, this very first sentence, substitute the values you found in steps 1 and 2 into the equation, blah, blah, blah. You do not have to do that because Hawks is assuming we're not using Excel, right? And I'm sure you've experienced that, like with standard deviation and variance. If you try to go to the help, it works it all out for you with the crazy math formulas, but we're not doing all that. We're using Excel to help us out. So this question, even though it seems super complicated, really all they're asking for is the slope of your line. So in class, we discussed what the slope of these equations means, and it means that if the value of the independent variable, that's usually your x, increases by 1 unit, then your dependent variable, your y, increases by whatever the slope is. So in this case, our slope is negative 1.735. So again, what that means is as our x value, our independent variable, when that increases by 1 unit, our y value is going to actually, in this case, decrease by 1.735 units. So let's enter that in, negative 1.735. How many? They don't even mention decimal places, so just type in the whole thing and submit. Okay, last one. Find the value of the coefficient of determination. All right, coefficient of determination, that is the r squared, which we found. 0.8835, but they want it rounded to 3 decimal places. I went ahead and just typed in 0.8835, but we need to round this 3 up to a 4 to make this 3 decimal places. There we go. And then this is a similar problem. I'm not going to go through this one again, but there is a problem like this on the exam review, which means it's very likely that there will be a problem like this on the exam. So just keep practicing. And if you have any more questions, please let me know.